Hello again. Let us now implement the first in first out queue using one-dimensional array. You can see that I have declared a structure queue there, and within which I have the item array with size, and the size is defined there with 100. And we have this rear and front within the structure. So when you create the object of queue structure, there will be an item array and there will be two integer variables, rear and front, for this queue. So we have these three operations for the queue. One is the init queue, that's going to initialize the rear and front. We need to pass the pointer to the queue to this function. The enqueue operation is going to insert the element that we passed to this enqueue operation into the queue. So we need to write another parameter there. So the first is the queue pointer, in which this enqueue is going to insert the element, and the second is the element, that's an integer value, that's going to be inserted into this queue by this enqueue operation. The dequeue operation is going to return the deleted element from the front of the queue that we pass into this dequeue function. We need to pass obviously the address of the queue object from which we want to delete the front. So let us now implement these operations. Okay, first of all, we need to implement the init queue. We received the queue there, the address of the queue object. Okay, so we first need to initialize the front, that should be 0. In order to access the member of the objects, we need to use the arrow operator, because qp is the pointer to the queue object, and I have discussed about all these things while implementing the stack. Also, if you are not conversant about the structure pointer and how to access the member of the structure pointer, I will strongly recommend to adopt the C programming course that I have there in the Udemy. So go through that course, that will make you much more conversant with the C programming language. Okay, let's move ahead. qp arrow rear, that has to be initialized with 0 as well. So the initialization is done. Now the enqueue operation, the first thing that we need to do in the enqueue operation is that we need to check for the overflow. So if the qp arrow rear, that moves up to the size, then it's overflow. You can remember the algorithm that we discussed earlier. Okay, here it is. If the rear is size, then it's the overflow case. Okay, so here we go. Printf q overflow, and we just need to return from this function that will terminate this function. Otherwise, if the queue is not overflow, we have provision for adding a new element at the rear. Then the first thing that we need to do is to place that value v at the rear position of the array. Okay, so the array is item, and that could be accessed using the pointer qp. So qp arrow item is the array, and we need to place the element v there at the index hold by rear. So here we go. V is assigned at the rear. Now we need to move the rear to the next index. So qp arrow rear equals qp arrow rear plus 1. So that's done. That's the enqueue operation. Now let us write the dequeue operation. First of all, we need to check if the queue is underflow or not. So qp arrow rear equals qp arrow front. In that case, the queue is underflow. That means we do not have anything left there in the queue to delete. And in that case, what I'm going to do, I'm going to return an absurd value from the queue. Since we have promised to return a value from this dequeue operation, you can see that the return type is int. So even if the queue is underflow, we must return something to terminate this dequeue operation. So what I'm doing, I'm just returning an absurd value from the dequeue when the queue is empty. Now, if this dequeue operation returns this absurd value, the caller will understand that the queue is empty. Otherwise, we can just pick up the value from the front, qp arrow item, that is the array, and we need to pick up the value from the front. So qp arrow front is the way by which we can access the front. Now we get the value there at v, just return v to the caller. So that's it, we have done the dequeue. Now in main, I have declared a queue object there, and we need to call the init queue for initializing this queue. So I need to pass the address of this queue. So the queue has been initialized. Now I will be calling the enqueue operation and dequeue operation. series of NQs and DQs, and we'll see how that works. So NQ, let me just insert. The first parameter is the queue, where address of the queue where we want to insert, and the second is the value that we want to insert. So I'm inserting NQing 5 there, and then let us say 10, 15, okay, then 20. So we are NQing 4 values there, 5, 10, 20, 15, 20. Now I'll be calling the DQ operation and printing the result that the DQ returns. Okay, so printf %d, because DQ returns an integer, first time, second time, third time, fourth time. So it's going to be 5, 10, 15, 20. And then if we call the DQ once more, the queue is empty, it's going to return -9999. A quick correction is required. You see that I have not moved the front to the next element. Here we need to move the front to the next element after picking up the value from the front. So front should be added with 1, QP arrow front +1. So let's go ahead and compile and run this program and see if we are correct in implementing these queue operations. Okay, let's go ahead. Here we go. Let me just compile this. GCC space FIFO queue, that's the name of the file, fifoq.c. Gets compiled, and now running the program. Okay, you can see that 5, 10, 15, 20, and ultimately it's -9999 when the queue is underflow. So it's working fine. Now in the next tutorial, I will add a nice menu to this program so that we can continue with the NQ and DQ operation. And after that, we'll see what's the flaw of these kind of implementation. There is a flaw, and we will dig out what's that. Keep watching. Thank you very much.